Content analysis is a versatile tool that can be used at any stage of the product development process, from ideation to market launch. By using content analysis to make data-driven decisions, companies can increase the likelihood of success for their products and services. Content analysis involves breaking down products into different attributes and attribute levels. This allows companies to identify product features that will appeal to customers and create different product bundles that can be presented to customers for evaluation. In content analysis, an attribute refers to a characteristic or feature of a product or service that is relevant to customers. Examples of attributes for a smartphone might include brand, screen size, battery life, camera quality, storage capacity, operating system, and price. For an airline service, attributes might include price, flight time, legroom, in-flight entertainment, food and beverage service, frequent flyer program, and on-time performance. Attribute levels, on the other hand, refer to the specific options or values that an attribute can take on. For example, for the attribute of screen size in a smartphone, the attribute levels might be 4 inches, 5 inches, and 6 inches. For the attribute of price in the airline service, the attribute level might be $100, $200, $300. In content analysis, multiple attributes are considered, and each attribute has several levels. By evaluating different product bundles that combine different levels of attributes, customers are asked to make trade-offs between the different attributes and attribute levels. This allows researchers to determine the relative importance of each attribute and attribute level to customers, and to identify which combinations of attributes are most appealing. The results of the content analysis can be used to make decisions about product design, pricing, and other factors that affect the success of the product. Content analysis is typically carried out in 3 stages: design, data collection, and decision exploration. Now let's start with stage 1, designing the content study. The first step in this stage is to select attributes relevant to the product or service category. This can be done by conducting a focus group study of target customers, asking the NPD team which features and benefits it would consider, or using secondary data such as consumer reports. For example, Nike, a leading sports apparel company, used content analysis to identify relevant attributes for their product development. Nike conducted focus group studies of target customers such as athletic and fitness lovers. In the focus group, the company asked customers about the features and benefits they look for in an athlete footwear and apparel, including aspects like comfort, durability, style, and performance. In addition to focus group, Nike also consulted with its NPD team to identify attributes that are important to consider. For example, the team might suggest including attributes like sole material, lacing systems, and breathability in the study. Lastly, Nike may also use secondary data, such as consumer reports and market research, to identify an appropriate set of attributes for its products. This helps ensure that the attributes being studied are relevant to the market and in line with industry trends. By combining insights from focus groups, the NPD team, and secondary data, Nike can select relevant attributes that are important to its customers and align with its product development goals. It's worth emphasizing that content studies, including more than 6 attributes, can be challenging to manage and may require specialized expertise. As such, for the purpose of this class, I recommend limiting the number of attributes in your content design to 6 or fewer. The second step in designing the content study is to select the levels of each attribute to study. Let's assume that Nike may choose attributes such as shoe style, color, material, size, and price, as these are relevant to the athletic shoe market. For shoe style, Nike may choose levels such as running shoes, basketball shoes, or cross-training shoes. For color, Nike may choose levels such as black, white, or various shades of blue, red, or green. For material, Nike may choose levels such as leather, mesh, or synthetic materials, etc. Several conflicting considerations come into play when selecting the levels of attributes. To improve the realism of the content study, Nike may choose to include a range of attribute levels that are similar to what is available in the market, such as popular shoe styles, common colors, and typical materials used in the athletic shoes. At the same time, including as few attributes and attribute levels as possible will simplify the respondent's evaluation task. For example, Nike may choose to limit the number of shoe styles to 3, such as running shoes, basketball shoes, and cross-training shoes. They may also limit the number of colors to 5 and the number of materials to 3. Typically, studies use between 2 to 5 levels for each attribute. To avoid biasing the estimated importance of any attribute, it is important to include roughly the same number of levels for each attribute. For example, Nike may consider including 3 to 5 levels for each attribute. If Nike were to include 10 levels for the color attribute and only 3 levels for the other attributes, respondents may be more likely to assign greater importance to the color attributes because they have more options to choose from. This could result in misleading conclusions about the true importance of each attribute. To avoid this, Nike should aim to include roughly the same number of levels for each attribute in their Conjoint study. In summary, selecting the levels of each attribute to study in a Conjoint analysis involves considering several conflicting factors such as realism and simplicity, and ensuring that each attribute has roughly the same number of levels to avoid bias. In step 1.3 of the Conjoint study design process, we need to develop product bundles for evaluation. However, with a large number of attributes and levels, the number of possible bundle combinations can be overwhelming. Let's say we are conducting a Conjoint analysis for a new coffee product, and we have 5 attributes with 3 levels each. The 5 attributes are roast levels, bean origin, flavor profile, packaging, and price point. To calculate the number of possible bundle combinations, we can use the formula number of combinations equal to number of levels for attribute 1 times number of levels for attribute 2 times number of levels for attribute n. In this case, the number of possible bundle combinations could be 3 times 3 times 3 times 3 times 3 equal to 243 possible combinations. A full factor design is used when we ask respondents to evaluate all 243 different coffee bundles. In a full factor design, all possible combinations of attributes and levels are presented to respondents. However, evaluating all 243 bundles can lead to respondents' fatigue and inaccurate responses, making it impractical to use in Conjoint analysis. To reduce the burden on respondents and still obtain meaningful data, researchers can utilize fractional factor designs. These designs are subsets of full factor designs that include a representative subset of attribute combinations instead of evaluating all possible combinations. This approach allows for a reduction in the number of product bundles evaluated without sacrificing accuracy. Orthogonal designs are a type of fractional factor design that not only reduce the number of evaluated product bundles, but also provide insights into the independent contributions of each attribute to the utility function. This ensures that the Conjoint analysis remains accurate and insightful, even when evaluating a reduced number of product bundles. To minimize respondent fatigue, it's recommended that the evaluation should include a maximum of 25 product bundles, and preferably 16 or fewer. In summary, in stage 1, designing a Conjoint study involves selecting relevant attributes, choosing a appropriate level of these attributes, and developing product bundles for evaluation. It is important to strike a balance between the realism of the study and the simplicity of the evaluation task for respondents. Now let's move on to stage 2, obtaining data from a sample of respondents. Step 2.1 involves designing a data collection procedure to obtain evaluations of the selected product bundles, which is a crucial step in the Conjoint analysis process. There are various methods that can be used to achieve this, including verbal, pictorial, or physical descriptions. While physical prototypes are desirable, their high costs make them impractical for frequent use. A common and cost-effective approach is to design a Conjoint survey that combines verbal and pictorial descriptions to present the product bundles to customers. This method allows for a more realistic and engaging evaluation process while keeping costs under control. I created a series of videos that demonstrate how to use the Qualtrics platform to create a Conjoint analysis survey. It is worth noting that Qualtrics is available for free for NDSU students, faculty, and staff, making it easily accessible for conducting research. There are several methods for obtaining evaluations from respondents, including pairwise evaluations, rank ordering, and rating scales. Pairwise evaluation requires the respondent to consider two or more products at the same time and allocate points among the options. However, this task can be tedious and burdensome. For example, if there are 16 product bundles, the respondents must evaluate 120 pairs, which is a significant amount of pairwise comparisons to make. This can lead to respondent fatigue and potential error in their evaluations, which can ultimately impact the accuracy of the results. Additionally, this method can be time-consuming and may not be the most efficient way to obtain evaluations from respondents. Therefore, it is important to consider alternative methods such as rank ordering or rating scale that can simplify the evaluation task while still providing meaningful data. The rank ordering method enables respondents to sort or rank the presented products. This approach has the advantage of being a simple task for the respondents as they only need to sort or rank the products. It also provides information about the relative preferences of the respondents. However, interpreting the results and determining the exact differences in preferences between different product bundles can be difficult. For instance, if a respondent ranks product A as their top choice and product B as their second choice, we know that they prefer product A over product B, but we can now determine the exact differences in preferences between the two products based on ranking ordering data. This method can also be sensitive to the number of products evaluated and the number of attributes included in each product bundle. As the number of products and attributes increases, it may become more challenging for respondents to accurately sort or rank them, which can lead to measurement errors and reduce reliability of the results. The third approach is the rating scale, which involves asking respondents to rate each product on a scale from 1 to 100, with higher numbers indicating greater preference. This method yields more precise and quantitative data on respondents' preferences, allowing for a more in-depth analysis of the results and the ability to identify smaller differences in preference among various product bundles. However, using rating scale requires more effort from respondents as they must evaluate each product on a 1 to 100 scale. Respondents may struggle to provide accurate ratings for all product bundles, resulting in missing or inconsistent data. It is crucial to understand that there is no universal data collection method that is suitable for all situations. Each approach has its strengths and limitations. Therefore, the choice of data collection method should be made carefully, considering the research objectives and characteristics of the target population. The chosen method should aim to obtain meaningful responses from the respondents while minimizing the burden on them. Step 2.2 involves selecting a computation method to obtain powers functions, which provide information about the relative importance of each attribute level in the eyes of the consumer. The powers utilities indicate how much a customer values each level of the attributes, and these values can be used to estimate the total utility of a product bundle. To analyze data collected in conjoint analysis, several models are available, such as hybrid conjoint models, adaptive conjoint models, and bridging designs. However, to keep the focus of this course on the practical application of conjoint analysis rather than the statistical side, we will not delve into the differences among the models. Instead, we will use engineered software to perform the conjoint analysis, and it will select appropriate conjoint model for us. To comprehend how to obtain powers utilities from customers' ranking based on preference, let's consider a straightforward example. Suppose you are in the market for a new smartphone and must choose between a 32GB model available off the shelf or a 64GB model that requires a 1-week delivery time. Your decision reveals your preferences for a combination of the attributes, in this case, memory and delivery time. The particular combinations of attributes you choose indicates the powers utilities of individual attributes, demonstrating how much value you place on each attribute. For example, if you select the 32GB model, it suggests that you prioritize a shorter delivery time over a larger memory size. On the other hand, if you choose the 64GB model, it implies that you prioritize a larger memory size over a shorter delivery time. Let's take a more complex example with three attributes: color, memory size, and delivery time, each with two levels, resulting in total of 8 possible combinations. With a full factory design, we can present all 8 bundles to customers and ask them to rank bundles from 1 to 8. The powers utilities can be obtained by applying a regression model, which is a statistical technique used to analyze the relationship between one dependent variable and one or more independent variables. In this case, the dependent variable is the customer's ranking of the product bundle, and the independent variables are the attributes and levels included in the study. However, we cannot include the text information describing the product bundles in the regression analysis, so we need to code the levels of each attribute using a coding scheme. We'll assign each level a value of either -1 or +1. For example, green is coded as -1 and red is coded as +1 for color. 16 MB is coded as -1 and 64 MB is coded as +1 for memory. And 1 day delivery is coded as -1 and 1 week delivery is coded as +1 for delivery time. We then use these coded levels to create design metrics that will be used in the regression analysis. In a virtual depiction, every combination is depicted as a point at one corner of a cube, where the first, second, and third dimensions correspond to color, memory size, and delivery time. The customer is then requested to rank these product bundles from 1 to 8 based on their preferences. In the regression analysis, the ranking variable becomes the dependent variable, and the attributes become the independent variables. We can use a multiple linear regression model to calculate the powers utilities. The regression equation y equal to beta 1 times s1 plus beta 2 times s2 plus beta 3 times s3 plus intercept assigns beta values to each independent variable to represent the powers utilities of the three attributes. Beta 1 represents the powers utility of color, Beta 2 represents the powers utility of memory size, and Beta 3 represents the powers utility of delivery time. Analyzing these beta values help determine the relative importance of each attribute in affecting the customer preference for the product. Beta values, also known as powers utilities, are obtained through a conjoint analysis software. For example, engineers can provide beta values for color, memory, and delivery. The beta for color is -0.5, the beta for memory is 2, and the beta for delivery is -1. To determine the attribute level importance, we need to calculate the powers utility for each level of attribute. This is done by plugging the beta value given by the regression reports and the value assigned to each level. For instance, if green is coded as -1 and red is coded as 1 for color, the powers utility for green is calculated as -0.5 times -1 equal to 0.5. And for red, it is -0.5 times 1 equal to -0.5. The greater the powers utility value, the more preferred the attribute level is. In this case, the green color is preferred over red because it has a higher powers utility value. Similarly, we can calculate the powers utilities for each level of memory and delivery. The results show that 60 MB memory is preferred over 16 MB, and 1 day delivery is preferred over 1 week delivery. We can then calculate the attribute importance for each attribute by calculating the attribute utility range, which is the difference between the maximum and minimum powers utility. For example, the range for color is 1, for memory it is 4, and for delivery it is 2, given the total utility range of 7. We can then calculate the attribute importance by dividing the attribute utility range by the total utility range and presenting it as a percentage. By doing this, we can see that memory is the most important attribute, followed by delivery, and color is the least important attribute. Now let's dive into the third stage of conjoint analysis, which is evaluating product design options. This stage is critical because it helps firms make informed decisions about which product bundles to introduce to the market. There are several steps involved in this process, so let's take a closer look. Step 3.1 involves segmenting customers based on their powers functions. Powers functions are essential because they reveal customer preferences for different attributes, which can vary across different segments. For instance, in a frozen pizza example, one segment of the customers might prefer thin crust pizza, while another segment prefers pan pizza. By segmenting customers based on their powers functions, we can gain insights into the unique needs of each group. We will learn how to conduct segmentation analysis in Module 3. Step 3.2 is designing market simulations. Once we have the powers of a representative sample of respondents, we can use conjoint analysis to simulate how a new product concept is likely to perform in the market. For example, we can predict the market share a proposed new product will achieve in a market with several existing competitors. In step 3.3 of conjoint analysis, a choice rule needs to be selected. The choice rule is responsible for converting powers into the product choices that customers are likely to make. There are three commonly used choice rules, which include maximum utility, shareable utility, and legit. Each rule has its advantages and disadvantages, but they all aim to distribute purchase volume across different product bundles based on their relative utilities. A detailed explanation of these choice rules will be provided in the next class. Step 3.4 in conjoint analysis involves adjusting market share to account for marketing programs supporting each product in the market. In a conjoint study, all participants are assumed to be aware of the new product. And the analysis assumes that everyone aware of the product will consider purchasing it and will be able to find it when it comes time to make purchase. However, realistic market share predictions must consider the marketing plans for both the new and existing competitive product in the market. Once the market share for one or new products are determined, the firm must decide which product bundle to introduce. While maximizing market share is desirable, firms must also consider their profitability objectives and constraints. In the upcoming week, we will explore how to adjust market share or profitability objectives in conjoint analysis in greater detail. To sum up, the use of conjoint analysis offers a robust structure for assessing product design options. Through the stages presented, company can obtain valuable information regarding customer preferences, create a simulation of market conditions, and make well-informed choices about the launch of their products. Conjoint analysis is a sophisticated method that needs to be applied with care. A well-executed conjoint study helps marketers distinguish between product attributes that people say are important and those that are truly important in terms of driving their preferences or choices. By conducting a conjoint analysis, we can gain insights into the unique needs of each customer segment, which can help us develop successful new products. Conjoint analysis has several limitations that should be taken into account. One such limitation is that it assumes that a customer's overall utility for a product is the sum of his or her utility for the component parts. This approach may not be appropriate in situations where a customer has non-compensatory preferences, meaning that they have certain deal-breaker attributes or levels that they cannot accept regardless of the levels of other attributes. For instance, a vegetarian customer would not consider a pizza with any meat toppings, no matter how good the other attributes like crust, cheese, and price are. In such cases, using conjoint analysis that includes meat toppings as an attribute could lead to misleading conclusions because the results will assume that the vegetarian customer will be willing to consider meat toppings if the other attributes are favorable. Therefore, it is essential to consider the decision context and customer behavior carefully before deciding whether or not to use conjoint analysis. Another limitation of conjoint analysis is that the validity of any study depends on the completeness of the set of attributes. However, including too many attributes can lead to respondent fatigue, resulting in inaccurate responses. Therefore, it is crucial to strike a balance between including enough attributes to obtain reliable results and not overburdening respondents with too many attributes. That's all for this video on conjoint analysis. We have discussed the guideline for conducting conjoint analysis and its benefits and limitations.